Hi everyone, welcome back to the Microsoft in 29 days self-paced course and welcome back to Geeks for Geeks practice. So just a quick reminder, in case if you have not registered yourself for the Microsoft in 29 days, so make sure to register for this course. It is free of cost. You can find the link of this course in the description of this video, and once you register and click on the start button, so as you can see here, you will be able to find the two videos for every day, right? You will see that two videos are there because I discuss two different problems on a certain topic and 5 problems you'll get to solve. The two problems that we do as classwork and other 3 problems on the same topic that I give as homework. So make sure to register for this course, because not only this, you can also track your progress amongst other people on the leaderboard as well. So make sure to register for this course if you haven't already. Let us discuss this problem, edit distance. So the problem says that we have been given two strings, that is one string is s and another string is t, and what we need to do is we need to return the minimum operations that are needed to convert s to t. So basically we are given the one string as s and another string as t, and we need to write a code in such a way that we get the minimum, like we have to do the minimum number of operations, right, to convert s to t. Okay, and what are the operations that we can do? The operations that are allowed to us are, we can insert a character to any position of the string, right? So we can perform the insertion operation. What does that mean? So suppose if the string is like, let's say geek, okay, and if the other string is, let's say GESEK, so you can see that this at this position what I can do is I can insert the string s. Okay, so this is what they mean by insertion operation. What they mean by removal operation: so suppose if the string that I want it to convert, let's suppose the string t is geek and I want the string s to get converted to t. So the string s, if we will see, if suppose it is like GESEK, so in this case I will remove this particular character, right? I'll remove this particular character so that it becomes same as t. So this is one removal operation that I can perform. Another operation is the replace operation. So if suppose that this particular string was, let's say x, okay, so if I see both the strings, so I can say that if this x string is there, right, if the character is x and this character is e, so I can basically replace this character with e. Okay, I can replace this character with e, and that's how both the characters, corresponding characters, will become the same, right? So these are the operations that I am allowed to do, and what we need to do is we need to find the minimum number of operations. Now whenever we see this kind of problem, whenever we have we have to do something in minimum operations, and here we have to basically replace, right? We have to either insert, remove, replace, such that the string the string s becomes equal to the string t in minimum operations. So we can observe one thing, that we can we can try to do what? We can try to do all the possible approaches, right? We can try to do all possible combinations, right? We can try to sometimes insert when the characters are not same. We can maybe try to insert, we can maybe try to remove, we can try to replace. And when we think about doing all possible operations, then which concept comes to our mind? It's nothing but recursion, right? Recursion comes to our mind whenever we think of doing all possible operations. Then recursion comes to our mind. So basically we can solve this problem using recursion. But let's say that we have been given the test case, right? Let's talk about the test case. So let's say we have been given geek and we have been given this the second string as, first string we have been given, let's say, as geek, okay, and suppose the second string t we have been given as g, e, s, then e, and then k. Okay, so what I can do is I can maybe start from the ending. Okay, let's say I start from here. So what can I observe? Are the characters same? Yes. If the characters are same, then I can simply move forward. Let's say I move to these characters. Are these characters same? Yes, they are same. So I can again move one step back, like to these indexes. And now if I will observe, so the characters are actually not the same, right? If the characters are not the same, then what are the possible operations that I can do? Either I can remove or I can insert. So suppose if the situation was like this, if I was having this kind of situation, like if the first string s was this and the second string t was this. So if I was at this character and this character here, corresponding characters, right? Because e and k were same in both, then in the first string I was at the character s, in the second string I was at the character e. So what can I do here? I can see that I can simply perform the remove operation, right? From the first string I can remove. So this is, suppose this is my I, okay, and this is my J. So I can say that I can simply remove this character. So in that case, what can happen? My I will start pointing here, correct? If I remove this character, if I take one operation and remove this character such that they become equal, right? So I can, my I will move one step back again, right? So in that case, what I can say is, if I am going to do the remove operation, right? If I am going to do the remove operation, in that case, we can say that I will go -1 comma j, right? Because I'm going to remove the ith character, so I can move my I here. I can get updated my I here, and j will move here. Okay, this is one thing that I can do. So let's write a little bit of code. Like, this is one operation that we can do. But suppose that we have to return. So let's say we write recursion, return recursion of, like, initially we also need to find the size. So let's say we are writing only recursion currently. So what I will do is, first of all, I'll find the size of the string. I'll have m is equal to the size of the second string, that is t. Okay, since we are passing using recursion, so I'll pass n-1 m-1 because that will be the indexes, the last indexes. n-1 m-1 is what I'll pass. n-1 is the last character of the first string, and the m-1 is the last character of the second string. Then I'll pass the string s, and I'll pass the string t as well. Okay, now in this case, if we will try to observe, so I will say that, okay, we'll write a recursive function here in which I'll be passing the I, I'll be passing the j index, okay, that currently that I am at, and I'll pass the string. So I'll pass the string ampersand s, because I need to pass it by reference, otherwise it will copy every time, which will take order of n time and m time to copy. So let's not think about the base conditions currently. What I'm saying is, if suppose that the ith character of the string, right, is equal to the jth character of the string t, in that case, what can I do? I can simply say that we can return what? We can simply return nothing, but we can move to the one character back, right? If both the characters are same, then we can decrease I and j by 1, and we can pass the string s and t for this particular recursive function, because we'll not require any extra move. Otherwise, if suppose that we are not having them as same, so if they are not the same, then we can perform various operations, right? And as I said, if I and j is not the same, right? As I said, suppose that I was pointing here, right? Suppose that j was, like, I was pointing here at this s, and j was pointing here. So one of the operations that I can think of doing is, if I is pointing here, so I can think of doing the nothing but the removal operation. If I do the removal of this string, then I will decrease by 1, and I should come here, right, next time, so that I can compare this I and this j, right? So if I'm doing the removal operation, so I will say that recursively I can call for I -1 comma j comma the string s comma t, right? So this is when I'm doing the remove operation. Now, is there any other operation? Are there any other operations that we can do? Yes, there are two more operations. So suppose in this case, if I have been given this string, like, suppose this is the current situation with us. Suppose the situation is like this. Let's say, so basically what I'm saying is, if you remove, right, if you remove, then in that case you will say that you will move I by -1 and j, right? Because if you're removing the ith character, then the next character that you want to check is I -1 and the jth character, correct? And suppose if you are here, right, suppose if you are here, the characters are not the same when you are here at this character and you are at this s. Okay, now in this case, what can I do? I can think of doing one more thing. The other thing that I can think of doing is, basically I can insert a s here, right? If geek is there, so suppose that I insert a s here, right? If I insert an s here, then this s will be same as this s. If they are the same, then which characters will I like to compare then? So I, like, if I is pointing here and j is pointing here, so now if this s and this s becomes the same, so now I'll move my j one step backward and j will come here, correct? Because I'll compare this character with this character, correct? Okay, so in this case, when I am doing the insert operation, right, in this case, if the character is not present, right, if the characters are not the same, suppose this is the situation, so I can do what? I can insert one character s here. Okay, if I insert one character, the same character here, in this case, I can say that my j should move to this, right? Because I want to check this e now with this e, right? Basically I want to check this character with this character. So if I'm inserting, then I will remain the same, because I will not move, because I've inserted one character here, and then j will move by -1, right? J will move one step backward. So the second choice that I could have had is that I could pass the recursion. Okay, I could be at I could have I the same j -1, because I'm inserting the character, and s and t I will pass. Okay, so this is when I am performing the insert operation. Okay, suppose this is when I'm performing the insert operation, right? But there's another operation that I can perform. Suppose suppose the string was geek. Okay, suppose the first string was X, and this string was GEEK. Okay, so suppose I was here, I was standing here, and J was standing here. So I have another operation, that is the replace operation, that I can perform. Okay, so if I have to perform the replace operation, so basically I can replace this character with the same character that is there. So I can replace it with E, and if I replace it, so now they will become same, and I and J both can move backwards. Like, so I will move here one step back, like I minus 1, and J will move here, right? That is one thing that I can do. So another thing that I can do is, the choice 3 that I can have is, I can call the recursion. Okay, I can pass it for I minus 1 comma J minus 1. This is when I am doing the replace operation. Okay, so this is nothing but the replace operation that we can do. Okay, now if I have to think, right, so if I have to return from this, so from these choices, so I'll always return the minimum of the 3 choices, correct? Because if these are the 3 types of operations that I can perform for the current I, so I will choose that one which gives me the minimum number of operations, correct? But still we have not thought about the other thing, about the base case. So when can be the base case possible? So if suppose this is geek string, okay, and this is geek also. Suppose that I moves here, right? Suppose I moves to minus 1, okay, and we still have some characters, let's say XYZ, okay, and now suppose J is pointing here, okay, J is pointing here. So according to indexing, this will be 0 1 2 3, okay. So J is pointing currently at 2, okay, if J is at 2, okay, suppose, and I is pointing here, right? I is pointing here where this index, actually I is equal to minus 1, right? So in this case, what can I do? I can simply observe one thing, that these many characters I need to insert into the second string, right? So I'll require how many characters? Like, I need to make the second string equal to the first string, right? I need to make the string S equal to the string T. So in that case, what do I need to do? I need to insert XYZ in the front of geek, correct? So if I want to do that, so how many characters are there that I need to insert? Can I say that I need to insert 3 characters? So according to J is pointing to what? J is pointing to 2, right? J is currently 2. So I need to insert J plus 1 characters, okay, because the indexing is 0 based. So that's why I need to insert J plus 1 characters, okay. So if it happens, right, if the base case is such that if my I is equal to minus 1, okay, in that case I will return J plus 1, because J plus 1 character, number of characters I need to insert. But other way around things can also happen, right? Suppose the case was like this. Suppose if XYZ and geek was there, okay, and the second string was geek, so if this was S and this was T, right? So in this case I can observe that when my I will move here, suppose what happens, I comes here, right? I moves here and J gets exhausted. The second string, I have iterated to the second string and it gets exhausted. So currently J is pointing to minus 1, okay. If J is pointing to minus 1, basically I'm saying, so suppose if J is equal to minus 1, in that case what can we do? So if J is pointing to minus 1, then I can simply say that I need to remove all these characters. And how many characters I need to remove? I need, if I see the indexing, so this is 0 1 2, so currently I will be pointing to 2, and if J has pointed to minus 1, so that means that the second string has got exhausted. So how many operations I require? I need to remove all these characters, right? So I need to remove how many characters? I plus 1 number of characters, because if I is equal to 2, so basically I need to remove 3 characters, right? Because it is 0 based. So in that case I will return what? I will simply return nothing but I plus 1 here, okay. So that is how I will be writing the recursion. Basically what I have done is, if I is equal to minus 1, then j plus 1 is what I will return. If j is equal to minus 1, then I will return I plus 1. Otherwise, if they are the same, then I will not require any operation, and I will call for I minus 1, j minus 1, passing the string as the same. And I'll try to see various possible scenarios, various possible combinations that are there. So I will try to remove, insert, replace, all the things I will try to do, and then I'll try to return the minimum number of moves out of them. So let's try and quickly compile this code to see if it works on the samples or not. Okay, it does not seems to work on samples. So what error are we making? Okay, I have not returned 1. Yeah, right. So one more thing that I need to do, if I'm performing this operation, then that means one operation is added, right? One operation, 1 plus recursion, right? 1 plus recursion, because if I'm performing the remove operation, it takes 1 operation, right? If I'm performing the insertion operation, it will also take 1 move. If I'm performing the replace operation, it will also take 1 move, plus the remaining part. I'll call the recursion for the remaining part. Now let's try and compile this and see what happens. So you can see we are getting the same output on the samples. Let's try and submit this code as well to see what happens. Okay, so when I submit this code, it gives me a time limit exceeded. Why is that so? Because in this what will happen, many of the states will be already calculated, because since we are talking about recursion, so the calls will be exponential in nature. But if you remember Fibonacci, right? So you know that if suppose I talk about Fibonacci of, let's say, 6, so it is nothing but Fibonacci of 5. You will call for Fibonacci of 5 and Fibonacci of 4. Similarly, you will call here for Fibonacci of 4. You will call for Fibonacci of 3. Correct? Here you will call for Fibonacci of 3 and Fibonacci of 2. Right? Then here you will call for Fibonacci of 3, Fibonacci of 2, and so on. Here you will call for Fibonacci of 2, Fibonacci of 1, and things like that in normal recursion. So you can see that if f of 4 is already calculated here, right? If you went so much down and calculated f of 4, so will you calculate f of 4 again? Will you calculate the fourth Fibonacci number again? No, you will not do that, right? Simply here also, if a particular state I comma j is already calculated, right? If suppose this is the recursive tree that I am making every time, I have 3 choices, right? So those, they also have 3 choices like this, right? This is the case here. So if I see here, I'm making it again and again. So if here a particular state I comma j for a particular value, for a certain constant value, it is already calculated, then if it is present here as well, so will you calculate it again? No, you will simply store it so that you don't have to calculate it again and again. In that case, the complexity will improve. It will come out to be order of n cross m. So let's see the dimension of the string. So they are saying that the dimension will be nothing but 100. So what we can do is we can apply dp here, and in this case you can say that int dp of 101, okay, 101, and we can initially mark it as -1, all the states as -1. So I'm using memset in C++. You can run a loop in other languages to initialize it as -1. Okay, so I'm using memset to initialize all the dp states as -1, and I'll check that if the dp of ij, if it's not equal to -1, if it is already calculated, right? If this particular state is already calculated, if the minimum moves for this state is already calculated, then I'll simply return it. I'll not calculate it again. And if it is not calculated, then what I will do is I'll simply calculate it, store it, and then return it. Okay, so I'll simply calculate it, and whatever value is returned, like whatever value is stored, like whatever value is there from min, I'll calculate it, I'll store it, and then return it. Okay, that is what I'll try to do in dp. So let's try and compile this. So it works on the samples. Let's submit this code as well. So you can see that our solution was able to pass all the test cases. Not talking about the time complexity of this code. So the time complexity will be nothing but order of n cross m, because we are checking for n cross m only for all these cells. Other than this, we'll not check for anything else. And the space complexity will also be order of n cross m, because we are using a n cross m dp. In case if you understood the explanation, so make sure to hit the like button and comment on understood as well. Thank you. In this video, we will discuss the problem egg dropping puzzle. The problem says that we have been given n identical eggs and we have been given access to a k floored building. So basically we have been given a building which has k number of floors. So basically we have n eggs initially, okay, which are identical in nature, and we also have the access to k number of floors. Okay, so k building, there is a building which has k floors inside it initially. So what we have to do is we have to find whether there exists a floor f, right? Whether there exists, like we have to find that there exists a floor f such that any egg dropped at a floor higher than f will break. Okay, so basically what we have to do is in this building we have to find the floor f such that any egg which is dropped from any floor higher than f will break. Okay, so if this is the floor f, then if the egg is dropped from this floor, or if the egg is dropped from this floor, any floor higher than the floor f, then the egg will break. And if the egg is dropped from the floor f itself, or it is dropped from any floor below, then the egg will not break. So if I drop it from here, so it will not break. If I drop it from this floor also, it will not break. If I drop it from this floor, if I drop it from this floor, so it will not break. So basically f is such a floor such that all the floors above f, if I drop the egg from any floor above f, then in that case the egg will break. Otherwise the egg is not going to break. If I drop it from f or any floor lesser than f, then it is not going to break. So what I have to find is I have to find this floor f in minimum number of moves. So let's see this, such that any egg dropped, and there are certain rules that we need to follow. So the rules that we need to follow is that an egg that survives a fall can be used again. Okay, so if an egg survives a fall, so it can be used again. A broken egg must be discarded. So if an egg gets broken, so it must be discarded, and the effect of the fall is same for all the eggs, and if the egg does not break on a certain floor, so it will not break on any floor below it. So suppose that if I try to drop the egg from this floor, if it does not break from this floor that I try to drop it from, then it will not break from any floor below it. Okay, that is one situation. And another thing, another condition that has been given is that, like, if the egg breaks at a certain floor, it will break at any floor above it. Okay, so if the egg, suppose that if the egg breaks from this particular floor, okay, so it will break from this floor, it will break from this floor, it will break from any floors above it as well. So these are the conditions that have been given to me. I need to return the minimum number of moves in which we can determine that what is the value of f. Now the problem statement is a little bit confusing because it is asking you the minimum number of steps, but obviously you have to think of one thing. If, like, there will be various cases, right? You will try to throw x in various circumstances, basically, right? So one thing that we need to keep in mind while implementing this problem is that we'll always be considering the worst case. Why? Because suppose that I ask you that what is the minimum time that you will take to do a certain task, let's say x. If I give you a particular task x and I ask you what is the minimum time that you will take, so will you give me the best case scenario that, okay, you will be able to do it in 3 days or 4 days or 1 day? No, you will not tell me the best case scenario, right? You will always tell me, like, you will think that whether you have exams, if you have exams, or if you have some other work to do, if you have some other pending work to do, so you will calculate that and you will give me the best, like the minimum number of moves or the minimum number of days in the worst case, right? You'll always think about the worst case that can happen. Maybe you might have some exam, maybe you might fall ill, so you will always give the scenario. You will always tell that, okay, you will always try to find the minimum number of moves or the minimum number of days, like in terms of, if I give you a task, so you'll always try to find the minimum number of days in nothing but the worst case. So here also, if you are throwing, so you will try to find the minimum number of moves in the worst case, right? You will always try to find the minimum number of moves in the worst case, that in the worst situation, what is the minimum number of moves that we will take. That is one thing that we need to follow. So what I can do is, suppose if I have been given a particular building, right? If I have been given this building, suppose. So if I have to think of all the possible ways, right? All the possible ways that I can throw it. So what comes to our mind when we think of all possible ways? Basically recursion comes to our mind, right? So what I can think of here is, like, suppose if I have initially, I have n number of x and I have k number of floors. Okay. So if I have nx and I have k number of floors, so in that case, what I can basically do is, suppose I choose, like, if I have initially k floors, right? If I have k floors, Smithy, so I can throw it from any floor. Okay. So suppose I throw it from any particular ith floor. Suppose I starts from 1, I is lesser equal to k. So suppose I try to drop it from a certain floor, let's say I, any ith floor. By running a loop, I suppose I have thrown it from a particular ith floor. So basically, if I throw it, so as we know, there can be two scenarios. Suppose this is the ith floor that I try to drop it from. Okay. And suppose there can be two scenarios, right? If I drop it from the ith floor, so either the egg will break, okay, or the egg does not break. These are the two scenarios that can happen. So if the egg does not break, then what will happen? If the egg does not break, right? If the egg does not break, then I can say that the number of x will remain the same only, right? If I think about it, then the number of x will remain the same. And if the egg is not breaking, so if from the ith floor, if the egg does not break, so that means from the I minus 1th floor, from the I minus 2th floor, from the floors below the I, it will also not break. Correct? So I will try to throw it from where? Like, if there were k total floors and I try to drop it from the ith floor and it does not break, so that means all the rest of these floors also, from the downwards floors also, it will not break. So what are the leftover opportunities for me? The rest of the floors that are left for me, from which I can try to drop it, is nothing but k minus I. We can observe this thing, that I will try to drop it from the remaining k minus I number of floors. Maybe it can break from there, but it will not break from the first I floors. That is very, very obvious. Okay. So in that case, I will try to throw it now from k minus I remaining number of floors. This is when it does not break, right? This is when egg, this was the condition when it broke, but suppose it does not break. So in that case, the number of x n remain the same, and the number of floors that I can say that are remaining are k minus I, right? The leftover upper floors that are there, I will try to drop it from there, because if it does not break from I, it will not break from any floor lesser than I, right? But suppose if I throw it from I and it breaks from I as well, so maybe it can, if it breaks from I, so maybe it can break from one floor down as well. I don't know. We don't know, right? So if it breaks from I, in that case, the number of floors, number of x will reduce by 1, and what will happen in this case? we can say that the remaining number of floors we can try to have I minus I number of floors, right? We'll have remaining I minus one number of floors, because if it can break from ith floor, maybe it can break from the downer floors as well, right? There's an opportunity for that. Okay, because it is not mentioned like that I is a threshold floor, we don't know. So in this case we can have a recursive call for this, and similarly we can have a recursive call for this part and this part, right? For every place, like we can try to move for all the possible cases, right? This is what we can try to do in the worst case. So what we will be doing here is we will be considering, like if we try to write a little bit of recursive code here, so what we'll do is we'll first of all write a recursive call in which we'll pass n. Okay, we'll pass n and k. Let's say we try to return the recursive call n and k, okay, where n is the number of x and k is the number of floors. So what we will do here is we will say that, okay, there is a recursive call, we have int n comma int k first of all. So if we have these things, so what are the base conditions for us? So suppose if I have only one egg remaining, okay, suppose the number of eggs that I have is just one. So suppose the number of eggs that are currently remaining with me is just one. If I have just one egg, so you will try to do what? If there are one egg, if there is just one egg and there are k floors, okay, so if you suppose try to drop it, if you have this, you have to think of the worst situation, right? So if you have one egg and if you try to drop it from this floor, suppose it breaks, then maybe there could have been a floor down here also what could have been the threshold floor, from which also it could have broken, right? So in that case, if it breaks from the upper part, if it breaks from upper floor and there is another floor down there from which it can break, so in that case I will not be able to find, because the number of eggs will get exhausted. So in that case I will try to throw it from down. I'll try to throw it from this floor first of all. If it does not break, then I'll try to throw it from this floor one by one for every floor. In the worst case, I'll try to throw it from the last floor, the kth floor, correct? That is what I will try to do. So in the worst case, what we can say is that if there's just one egg remaining, in that case we can say that we will return k, because k we will try to drop it from the starting floors till the kth floor, okay, because we just have one egg, so we cannot take any chance, right? We have to be very safe while throwing. Another thing that we can observe is that suppose if it happens that k is equal to, let's say k is equal to 0, okay, if the k value becomes 0 after certain recursions, in that case we can simply return 0, okay. Suppose if the k is equal to 1, if there is just one floor, in that case also we will return 1 only. So we can say that if it happens that n is 1 or k is equal to 0, okay, or k is equal to 1, in those cases we can simply return k. That is one thing. Apart from this, what we can do is we can mark our answer, let's say, as int maximum, okay, initially, because we want to find the minimum out of all the worst cases, right? So initially we'll mark our answer as int max, and what I'll try to do is I'll try to run an I from I starts from 1, I is lesser equal to k, then we'll do an I plus plus here. After this part is done, so what are the chances? Like the chance one can be that suppose I throw it from the ith floor and suppose that it does not break. So if it does not break, like suppose that it breaks, right? So if it breaks, then in that case I'll have one egg less, n minus 1x, and the number of floors that I can try now is I minus 1. Okay, so I'll call the recursive call for n minus 1 number of floors, like n minus 1x, because one egg has broken. So this is when the egg breaks, right? This is when the egg breaks. In that case, n minus 1 and I minus 1. Otherwise, what is the chance 2? The chance 2 is that I can call the recursion call. Okay, I can call the recursion. The chance 2 is that the egg does not break. If the egg does not break, then the n number of eggs remain the same, and I will try to throw it from the remaining floors. From like if it does not break from I floor, it will not break from any floor below I. So the remaining number of floors for me is nothing but k minus I. Okay, that is the case here. So this is when the egg does not break, right? This is when the egg does not break. After this, what we can try to do, so we can say that the worst case scenario is what? The worst case scenario is nothing but, like, since I am taking one move here, right, because I am trying to drop it, right? So one move is taken here, and then if I'm talking about the worst case, so I'll always think about the maximum of the chance 1 comma the chance 2, right? The maximum, since I'm talking about the worst case, so it will be nothing but the worst, like it will be the maximum of the chance 1 comma chance 2, and then I'll update my answer as nothing but answer is equal to minimum of, I'll always try to minimize the worst case, right? So answer is equal to nothing but minimum of answer comma the worst case. Okay, Once we are done with this part, so what we will be doing is, if the answer is calculated, after that, what we can do is we can simply return the answer that has been calculated. Okay, so let's quickly try and compile this code and see if it gives any errors. Okay, it seems to work on the samples. Let's try and submit it and see what happens. So when I submit this code, you can see we are getting a time limit exceeded. Why is that? So why is it taking so much time? Because this is recursion, and you have to think, like, for if suppose there are certain I, right? Suppose I am currently trying to throw it. Suppose n comma k is there, right? So there are I different floors, right? I different floors. For a larger value of k, you can see that there will be a lot of circumstances. Then for this case also, there will be a lot of circumstances, correct? Like this here. Then there will be various circumstances. Then here also there will be various circumstances. So you can see that the recursive call will be exponential in nature, because I'm calling for a lot of functions again and again. Okay, so what you can observe it, suppose this is a particular recursive call, right? Suppose this is a particular recursive call. Let's say this is suppose this is n is equal to 3 and k is equal to 3. Okay, suppose or suppose this is n is equal to 3 and k is equal to 2. Okay, so this is the situation when I have 3x remaining and the number of floors are 2. Okay, this is the situation, and I can say that maybe this, suppose that this case was also where this recursive call was when n is equal to 3 and k is equal to 2. So if I have gone so much down, if I'll go down for this case and I'll calculate it, if I have already calculated it, will you want to calculate it again? And there can be various states. Let's say this state is already calculated and you're calculating it again here. So is it feasible? No. In that case, the complexity of the of our code will be exponential. So what we can do is we can use something like dynamic programming. Or we can say that we can use memoization, right? Because if a particular state is already calculated, we'll not calculate it again and again. In this case, if a particular value of n and k, right, if it is already calculated, then I will not calculate it again. Otherwise, it will increase the complexity of our code. So what we can do here is, instead of that, if we want to calculate some values only one time, so what we can do is we can basically say that we can apply DP here. That is nothing but memoization. So first of all, let's check what will be the dimensions of our DP. So here, if you'll observe, so n and k are given as 200. So we can take it as 205. The DP maximum size can be 205, like 205 for each dimension. So 205 and 205. Okay. Then what we can do is, I can initially say that I'll set all the values as -1. So memset of dp comma -1 comma size of dp. So basically I'm initializing all the states as -1. Okay, and after this, what I will check is, I'll check that if the suppose that if the dp of n and k, right, if the dp with like if the current state where n number of x are remaining and k floors are there, if it is not equal to -1, right, if it is already calculated, if this particular recursive call has already been calculated, in that case I'll not go down again and calculate it, because I have already stored it. So I'll simply return it. This will save a lot of recursive calls from happening. Okay, and then here also, if it is not calculated, then I'll go down, calculate it. Okay, so in that case, if it is not calculated, I'll go down, I'll calculate it, I'll store it, so that next time when I come back, so it will no longer be -1, so I can directly return its value. So I'll calculate it, store it, and return it, so that the next time when we come, we have to not calculate it again. Okay, so this is what we will be trying to do. Let's try and compile it now. Okay, so it seems to work on the samples. Let's try and submit it as well to see what happens. So you can see that our solution was able to pass all the test cases. In case if you understood this explanation, so make sure to hit the like button and comment down understood as well. And one more thing, the time complexity of our code will be nothing but order of n cross k, because we are calculating each and every state exactly once, and the space complexity will be also order of n into k. In case if you understood, make sure to hit the like button and comment down understood as well. Thank you.